So today we have Northwest Natural Resource Group's forester Matthew Schmidt, who is going to be talking about forest pests and pathogens. And thank you, Matthew, for being willing to chat with us today. I know this was a recent topic at some of the conferences that you were attending, and always something that people really see on their lands and are seeing on their properties. So interested to hear more, and I can turn the microphone over to you if you'd like to get started.
Okay, yeah, thank you, Rowan, and welcome everyone. Thanks for showing up. Um, yeah, looking forward to talking about Northwest pests and pathogens. I think as a forester, it is a question we get all the time. What is wrong with my trees? Why are they dying? And we don't always have the answer. It's a complex field. I'm not a forest entomologist. I'm just a generalist who has dug into some of these topics in my education, but there's a wide range of information out there. I'm trying to distill some of it for us today, talk about some of the heavy hitters in our neck of the woods, and then yeah, discuss some of the management options that are available to us if one of these pests or pathogens was causing a problem on our forest. So let me share my screen real quick. Um, Tell me if this is working well.
Yep, can see it.
Looks right. Okay. Um, Great. Let me just move a little. Okay, cool. So yeah, pests and pathogens, a fireside chat. So let's jump into it. We want to just kind of talk about what is a pest or a pathogen, kind of root that in our discussion of management objectives and planning, and then hit on some of the major topics in our region. Three major root fungal pathogens, one major insect pest, and then maybe a couple others if we have time. But I think this will take quite a bit to get through. Um, and then we'll open up some questions um, and yeah, maybe we can talk about some of the pests or pathogens you've experienced on your property. Um, so right off the bat, what is a pest or a pathogen? Um, I think this is important because all of the things we're going to talk about today occur naturally all the time in most parts of your forest. It's only occasionally that they may cycle up to a higher intensity and they may start to cause you some problems. And problems is really how you define this. So it's really depends on your objectives. You know, all of these pests or pathogens operate as small scale disturbance agents. So they can increase your stand diversity. Um, a lot of times we think of these pests or pathogens we'll describe as kind of natural features of your forest. And only when they sort of go out of control or are working against your objectives, then they become something that needs fixed or something that you want to manage with the outcome in mind. Most of the time, though, we can let these small scale disturbance agents work their magic and increase the spatial diversity and the species diversities of our forest. And when they can cause problems, though, it's because they reduce forest growth or increase mortality. That can lead to lower timber values. That can reduce the species that are suitable for your site, kind of limiting some of your management options. So they can get in the way of our objectives in the forest. And so a lot of this just really depends on what your objectives are. And that's going to be the lens you look at when you decide if this insect outbreak is a pestilence or if this fungal pathogen is causing you a problem that needs mitigated. And so it's just really important to remember that there is no one size fits all answer. It really has to be filtered through your objectives. Um, with that in mind, the first one I want to talk about is fungal root diseases. This is something we have a lot in Washington and Oregon. Uh, Probably on most people's forested property, there's going to be some fungal root diseases going on. We know root funguses are everywhere in the forest. They're part of the web of fungal connections. Um, but many of these funguses can cause death in trees, and that can be contrary to some of our objectives. So the root diseases are fungal funguses that specialize in attacking tree roots and often the lower butt of a tree, so up the stump, maybe 6, 10 feet high. And they decay the wood there, causing problems for the tree. So here are some mechanisms. These root diseases primarily spread in root-to-root contact. Really, the roots need to be almost touching for these funguses to spread from an infected tree to an uninfected tree. You can kind of see in this picture here how there was an infected tree in the middle of this, and it's spreading outwards, reducing growth and killing trees out from the center of the outbreak. Um, What's notable about these is that they are funguses that can survive in dead material, decay in dead material for many, many years, up to maybe 60 years in some cases, and then still reinfect living tissue, living roots that come back into contact. So you can have an infected tree, it can die, and its roots that are left in the soil are refugia for that infection for many years, decades, and then a new tree growing there can become reinfected from that pathogen from decades ago. Um, and that means that these are basically um, diseases of the site. That once they're there, they're very hard to completely eradicate, and we have to sort of live with them or work with them. Like I said, they cause decay in the roots in the lower butt, and it slows growth and it leads to eventual death. Pretty uniformly, most trees are going to die over many decades gradually um, once they become infected. And the tolerance of the trees varies by species. Some root diseases target very specific species, some are more generalist. But all trees all conifers are susceptible when young, or all the species, all the fungal pathogens we're going to talk about today can infect any conifer when it's young. Um, and it's only kind of when the tree grows older, they establish some tolerance and can live with that infection um, and not succumb to it. So this is a little bit, this picture kind of iterates this or illustrates this idea that of a spreading a disease, root to root contact. And we'll get a couple more pictures here of how that works. So when you're out in the woods, what does that look like? Here's a picture of one of these spreading disease centers where we have um, some really dead trees in the middle, some dying trees on the edges that are starting to show stress and decline. And so that's one of the main things we see is declining trees with reduced growth, thinning crowns. They are effectively the trees are losing root mass. So as their roots decay, they're running out of the critical, pipeline that powers their development. They can't bring in sufficient moisture and nutrients, and so they're unable to grow and they can't support as much foliage. Sometimes as they're dying, they'll put out a stress crop of cones and one last attempt to continue their genetic legacy before they die. But when you stumble on these gaps in the forest, they're fairly clear. They look, like something has slowly been declining in time. Um, and then there's these dead trees that have already succumbed, these snags. One of the most characteristic signs is when you look at a snag, or sorry, a wind-thrown tree, it will have very few fine roots. If you look at a tree that's tipped over because of a mechanical failure, like a really big windstorm, and that tree tips over, it's going to have a huge root plate, right? This like big amount of fine root material and a big wide radius. When a fungally, root infected tree tips over, there's almost no root material left. We'll see a picture of that. And it's just very stubby, just the biggest root branches are left. And that's what that tree was working with when it died. All of its fine root material had decayed, and that's why it wasn't able to continue living. And this results in these growing disease centers where you have dead trees in the center, dying trees on the edges, and in this disease center just kind of marches out slowly over the decades from these initial sites. Um, in most root diseases, this can take decades. So a lot of times we don't see decline until the trees are much older, like 60 plus years. And so it's not uncommon for people to not know they have a root infection because the trees are able to live with this disease for many decades before it finally catches up with them. So we see that a lot. People are, you know, trees get sort of 60 plus years old, they start to decline, and often it is just a root pocket that's been there for a long time but wasn't exhibited earlier. Um, so these are some pictures. Here's another great picture of this is a tree that tipped over from a probably laminated root rot, but a root disease, and you could just see that there's like very little fine root mass, just kind of big stubby roots, and that makes them really prone to tipping over in windstorms because they don't have a lot of root to hold them on. But we'll kind of run through three of the big players out there, talk about some of their diagnostics so you can try to decide if you have a disease patch, which root disease you might have, and how your management might change as a result. Um, so the first one, and one of the biggest in the Northwest, is laminated root rot. And this is one of the most damaging, kind of commercially damaging fungal pathogens in the Northwest. I think in a study of Western Oregon for Western Cascade forests in Oregon, something like 8% of Douglas fir forests were infected, 8% of the area, and were in these root rot pockets, and up to 50% of the trees were dead in each of those pockets. So can have a pretty big impact on the growing of these highly susceptible species. So um, with laminated root rot, there are some diagnostics that are really key. As the name suggests, delamination of the decay. It separates the ring growth in a tree really clearly when it dies, and you have these kind of laminated layers that pull apart. Um, that's the top image, I think, shows pretty clearly. The bottom image shows a brown sort of, well, it's a hyphae, cetal hyphae, and that's part of the fungus growing here in this brown area in the bottom picture. And this is a little harder to see, but if you were to freshly cut a tree, they frequently have a reddish brown stain in concentric rings, but it'll fade with time. So this isn't the best diagnostic. If you're not right there cutting the tree, you might not know. Um, and this is a damaging pathogen because Douglas fir is highly susceptible, perhaps the most susceptible, as well as some other trees, silver fir, grand fir, mountain hemlock. Western hemlock, spruce, noble fir have some medium susceptibility. But as you'll come to see, a lot of these root rots, they have different hosts. And so you can kind of work with different species based on the susceptibility of the fungus in your forest. So laminated root rot is so common that I think 7 out of 10 times when I see a root rot pocket in a landowner's forest, it's probably laminated root rot. It is especially in a Douglas fir forest, it's going to be the main agent of root rot. But let's jump to the next one. This one is interesting. This is a gnosis root disease. Um, targets slightly different species, grand fir, silver fir, and notably hemlock, as well on the east side of the Cascades, pines. This one is also pretty common, but because it doesn't really, Douglas fir isn't susceptible, we don't see it quite as often. And it is diagnosed by a conch in older infections, like in the top photo, this kind of white, hard mushroom conch. And if you were to chip off a piece of a tipped over tree and see kind of pitted decay with white pockets or black specks, like the bottom photo, that would get you a better sense of its zoonosis. The conch is not always present if it's a young infection. So um, I sort of diagnose this one more if it doesn't look like laminated root rot, then it's probably a gnosis. Because the laminations are very, very clear when you're picking up a piece of dead wood. Most notable about gnosis and why we even have it in this presentation is that it can spread via airborne spores from that conch. It can release airborne spores. So whereas the other root diseases I talked about root to root contact, which means they're slowly spreading, laboriously moving feet per decade throughout the forest. Anosis can colonize fresh wounds, such as stumps, and as a result, it can be spread by thinning. And so that really plays into management decision making if you suspect you have an anosis disease. Since it is not common in a Douglas fir dominated forest, for many of our lowland landowners, this isn't going to be a major concern. If you start in a higher elevation forest, silver fir becomes really dominant, as does hemlock or grand fir. And this can be a pretty interesting disease to try to work around the management um, and being aware of. So that's the top two. Let's jump to the third one, though. Armillaria is a really widespread disease. It doesn't, though, cause as much damage as the first, as laminated root rot, and it's pretty easily diagnostic. When you chip away at a dead tree or a freshly dead tree, like in this photo here, you find a thick white mycelial fan. Um, it's and you can't rub it off. Like it's like a chunky bit of mushroom living underneath the bark right there. And so it's pretty clear that it's going to be armillaria if it has that. The Armillaria genus is what we would I think call honey mushrooms for anyone that's out mushrooming. Not going to say which ones are which and how that all works because I'm not sure it's really all that clear. But Armillaria malea is the most common, the one that we're talking about here for root disease. And the decay, when it finally does die, is yellow, stringy, and kind of shredded. Um, a notable thing about it, though, isn't really a major management concern, is that it also has a minor capacity to spread through the soil. And so, even if a root doesn't come in contact with an infected root, it could come in contact with an infected part of soil. And that's sort of another minor notable feature. But in the management of this disease, that's not doesn't really play a big role. All conifers are susceptible, but some species, like Douglas fir, can achieve a tolerance or resistance once they're about 20 years or older. And so that's an important kind of thing to remember is that a lot of trees are most almost all conifers are susceptible to these diseases when they're young. Um, but most of the time, if they can grow fast and reach 20 years of age before succumbing to the disease, they can continue living. So that would be for armillaria. That's not going to be for laminated root rot, which is much more of a killer on the landscape. So those are our big three. And so when we're trying to figure out why that patch of trees died, trying to fit the disease into at least these three buckets. You know, there are more buckets. You can really get into it, but if you can figure out if it's one of these three, then you can come up with a strategy for managing or living with that disease. So I wanted to highlight those three and then jump into, what does it mean to manage or treat these diseases? And the first reality is, I think I mentioned, these diseases are diseases of the site. They're nearly impossible to truly eradicate. Um, Most of the time, we're looking for ways to mitigate outcomes to better meet our management objectives. Uh, and so sometimes for a low level infection that's not affecting your goals, no intervention would be really, really common. We see these infections as agents of stand diversification, and they help achieve a lot of our clients' management goals, introducing canopy gaps, allowing other species to thrive, creating a more structurally diverse forest, reducing the homogeneity. So that is really probably the most common recommendation I give is just probably don't need to intervene if it's at a low level and it's not really affecting your management goals. Um, when it is affecting your management goals, really the best option is just to plant tolerant species. You can plant into that expanding disease center, that gap. And these tolerant species are going to broadly be, hardwoods, pines, and cedars. And these are going to be quite resistant to the three diseases we already mentioned. If you're able to identify which disease it is, you can get more specific. Like you could plant armillaria or you could plant Douglas fir into an armillaria root rot pocket, or the same with anosis. So you can choose your tolerant species, and that's probably the best way. That also increases your diversity, and you're not trying to stop what is kind of a unstoppable force. Um, and when you do these plantings, though, you really need to maintain the seedling. Since a lot of these species can still be affected when they're young, we really want to make sure these seedlings can grow quickly and reach an older age where their age-related tolerance begins to really, help them survive. If we just plant some seedlings and abandon them and they don't grow well, they could succumb to the root disease before they reach this kind of age-related tolerance. Another option is just broadly improving the vigor of your overstory trees. They are infected or about to be infected with a root rot. Um, and as they lose fine root material, it's harder and harder for them to survive. You can never stop the spread or the decline of root rot. It's inevitable that tree, once infected, will die. But if you improve its vigor, if you reduce its competition, if you increase its access to soil moisture, you can delay that mortality. Now, I've been to sites that are heavily infected, but have a really high water table and are able to live on just a few roots, and they're able to soak up just enough water because they don't have to try very hard to get water. They don't need to have a massive root fan. And because of that, they can sort of mask the fact that they are in decline. Um, so you can improve the vigor and delay that mortality, but you can never really escape it. But that could be in your management goals. Maybe you want to delay mortality for some other objectives like a later thinning harvest or maintaining trees longer on your property. So that's another good option. Um, there are some other options that are difficult and expensive, but I'll lay them out here for you. Sanitation cuts are possible. If you know definitively where the root rot is on your property, you can cut all around that, plus some distance away to ensure that you remove the potential linkage between living trees and dead trees. And then you wait 60 years, and eventually that soil could become useful for you again, or you might plant, tolerant species in there. But the problem with sanitation cuts is that it's really hard to actually know how far the infection already spreads. And if you miss even a couple roots that go through your sanitation cut, you really didn't gain anything, and the disease continues to spread. So it's difficult and expensive to do this right, but in trials, it has succeeded. And stump removal is even higher chance of success. You physically remove this infected material from the soil, and you reduce the amount of time that fungus can stay in the soil, but it's very expensive. I mean, pulling up all these roots, cutting these trees, pulling up these roots. So it's just not really something that you see done, except for university scientists who were studying this. Um, there are a couple other options I'll run through real quick. One is, if your trees are going to have reduced vigor and die sooner, you might move up your thinning harvest, you might shorten your rotation. And this is sort of the solution that commercial industrial forestry has come on. A lot of industrial timber just plants right through root rot pockets, but cuts their trees, very young before major decline has occurred. Since most of our, most people on this call are probably interested in growing older trees and not clear cutting. This is not such a common recommendation, but if you had a strong interest in timber value, might move up some of your activities to account for the fact that you're going to have a slower growth in the future. For anosis in particular, we have two options. We want to avoid wounding trees, especially if we were going to be thinning. And with anosis, you can preventively treat stumps so that if you did thin, as you see in this picture on the far right, um, a freshly cut stump is a wound that could be infected by anosis. But if you treat it with effectively borax, there are some over-the-counter formulations, but effectively borax sprinkled on the stump will prevent it from becoming infected. which allows you to continue thinning in an area that might have an anosis outbreak. So that's a fairly low cost solution, and worth remembering. If you have a anosis and you're in like a hemlock or a silver fir stand, that's a decent option to still meet your management objectives. Um, all right, that's the fungal root diseases. I want to just jump through one major insect pest here as well, and I'll just start with insects are always present, right? They're a natural part of the forest, but they can occur in outbreaks, and we often think of them as occurring because there's a lack of natural control on their life cycles. Because their natural life cycle is cyclical, or really the one I want everyone to remember, because trees are stressed. And this is why we have most of our insect pest outbreaks in the Western Cascades. Stress trees. Insect pests are almost never a primary disease agent, like a fungal pathogen is very frequently is the primary disease agent. Insect pests are opportunistic. They come and attack an already stressed tree. Maybe a tree that's dealing with a serious, disease, root rot disease, and then it gets hit by a bark beetle, and that's really common. And so insect pests are typically secondary infestations. Um, and I just want to talk about a couple major players, and we'll just go into one of them today, though. But bark beetles are major players. They can eat their way around a tree, girdling it and killing it. Wood boring beetles, they can go into the tree and they cause holes and defects in your lumber if you were selling lumber. And some of them can kill trees depending on their mechanism. Defoliating insects, they remove needles or leaves from a tree, and that reduces growth. Um, and sap-sucking insects, kind of like aphids, that reduce growth and in some rare instances also kill trees. So these are sort of the four major categories, but the only ones that really cause a lot of damage in the Northwest are going to be bark beetles, and we can get into those quickly. Um, Here's sort of a table from the Oregon Department of Forestry that outlines different species and their common insect pests. You can see there's a fair amount for Douglas fir and a fair amount for pine, but there's like almost none for hemlock, and in the cedar category, they're all considered secondary or aesthetic pests. So it is interesting that when we talk about insect pests, we're not really talking about every tree. We really focus often on Doug fir, a little bit on the true firs. And if we live, this is the Western Cascades, we don't really have a lot of pine, but pine beetle outbreaks, have clearly been in the news for the last decade or so, like the Western or the mountain pine beetle. Um, but the one I want to talk about are some bark beetles. These do occur in Western Washington. They're very small. Like I said, they're opportunistic. They typically attack trees that are already stressed. And unlike a wood boring beetle, a bark beetle lives under the bark, not in the wood. And by living under the bark and eating the phloem of the tree, they girdle and effectively kill that tree. They have very predictable life cycles, so we can come up with management scenarios that work around the life cycle of those beetles. And they are host specific, like you saw in that last table. Only certain trees have bark beetle outbreaks. Um, because they live under the bark and not in the wood, their major diagnostic category is going to be brown frass or sawdust. If it's a wood boring beetle that's going into the tree, the frass or the sawdust is often white, and the brown comes from eating that inner bark. So if you see brown frass, like this upper right picture, you know you're working with a bark beetle, 9 times out of 10. Often on the tree where the beetle entered the tree, there's going to be a single stream of pitch, like the size of a small hole and a small pitch stream. If you see a massive stream of pitch, that's something different. It's just going to be like singular pitch streams. And then all bark beetles have distinct galleries. And that's really how the entomologists identify what beetle they're working with. So you can see in the bottom right, this is a gallery where a beetle came in, laid its eggs in overwintered, laid its eggs, and then new beetles hatched out in every direction. Um, they also have tiny round exit holes. But the only beetle we really worry about in the Western Cascades or the whole Western Pacific Northwest, let's say, is the Douglas fir beetle. And this is a really small, it's about the size of a grain of rice, quarter inch or so. and it really only infects Douglas fir trees over 10 inches in diameter. And it really prefers dead trees. So it's triggered by dead wood events like blowdown, mortality, or maybe a non-commercial thinning. And then it can build up sufficient populations in the dead wood that it will then attack living trees around it. And often, though, a Doug fir tree can actually survive a beetle attack. It can push enough pitch, it can stay ahead of the beetle. But if it's stressed, it's likely to succumb. And so we can get these outbreaks. But they're limited in scale, right? When we think maybe of bark beetles, everyone's probably thinking of the pictures of Colorado 5 to 10 years ago with massive hillsides completely dead. That doesn't really occur with Douglas fir beetles. They're very small outbreaks, maybe an acre, 5 acres would be like a fairly big one. And they're more individual trees because it's about which trees are able to beat the beetle and which trees succumb. Um, and then because they have a predictable life cycle, they're active from April to August, and that'll help us, make some plans for dealing with down wood before it triggers a big beetle outbreak. Um, so some diagnostics that help you while you're out there is, like I said, the frass and the pitching on the stem. Um, yellowing foliage shows that the tree is dying, and so that'll help you determine if a tree's in decline. And then you look at the stem and you see some brown frass. You're probably likely dealing with and it's a Douglas fir. This is really important. Often when I'm in the woods and I'm trying to figure out what killed these trees, a really good sign is did it kill multiple species of trees or did it kill a single host tree like Douglas fir? And that can help you identify it. Uh, in the bottom right corner picture here, we have a Douglas fir tree that had all of these little conchs, these little mushroom fruiting bodies, are where a beetle entered the tree and carried with it a fungal pathogen. So it's a secondary, this tree is dead, but in the death of this tree, a secondary fungus grew here. The fungus did not kill the tree, but it just like really shows you really clearly, like, wow, a lot of beetles were in this tree, and that was too many beetles for the tree to live. Um, so that's the thing about Douglas fir beetles. And why do we even talk about Douglas fir beetles? The main reason we talk about it is because of dealing with dead wood. Um, a lot of times, if you're creating dead wood in the forest, or dead wood were to occur naturally from a big blowdown or a storm that leaves a lot of dead wood, you might begin to consider what could happen with a Douglas fir beetle outbreak. If you're with our clients a lot, there's people are trying to thin, but they might have inaccessible stands. They're trying to reduce the tree density, improve forest health, but they don't think they can get the trees out of the woods and sell them, so they're going to leave them in the woods, right? And these are bigger trees, so Doug fir beetles in the 10-inch and above class. Um, and if you're going to create a lot of dead wood through a non-commercial thinning, then you need to really consider and plan for additional mortality that's likely to occur from beetles. There's some rules of thumb. Um, some entomology, I think we hold them very loosely. I've been advised that they maybe aren't the best rules, but Forest Service publications suggest that 6 live trees for every 10 dead trees. So if you cut and drop 10 dead trees in your forest, you should plan on 6 more live trees that you wanted to keep succumbing to a beetle over the next 3 years. So if you plan ahead, you can work with that mortality, but it is sort of, risky, and nature does not live by these equations at all. So a lot of times we really suggest, trying whenever possible to remove the dead wood, effectively to sell it. Or if you're really have no choice or you choose to leave it in the woods, then just be cognizant of what could occur. And so we're always really, that's the real tension between non-commercial thinning and Douglas fir beetle potential mortality. Um, a lot of time, though, there is no reason to intervene. It's a low-level infection, not affecting your goals. And like I said, it adds and improves stand heterogeneity. A 1 acre beetle patch killing 16, 18-inch trees in a mature forest creates a lot of high-quality snags for woodpeckers and other birds. And it's isolated. It's just 1 acre. It may not be contrary to your management goals. Uh, if it is, though, if the Doug fir beetle outbreak is occurring or you don't want it to occur, it's really critical you remove dead wood before April. And so in April is when the beetles that will come hatch and infect your forest. So if you had a storm or you cut some trees in July, those trees will become infected with beetles, but they won't. The larvae won't hatch until April. So you have until April to get rid of those trees and stop that explosion of new beetle larvae from infecting more trees. Um, there's also a really effective pheromone repellent called MCH, and this is a little expensive, but it's highly effective. And you staple at the bottom right corner. They're little caps in plastic tape or metal tape that you staple to trees, and there's different rules for how many you need to place, but you can place 20 to 30 per acre, and they cost I don't know, probably at least $3 a tab today. So it can add up quick if you're doing a large area, but they work really well. The pheromone actually mimics the pheromone a Doug fir beetle puts out uh, when it wants to signal to other beetles that the tree is full. There's no space here. And so this MCH repellent mimics that naturally and sort of is very, very effective at stopping infestations. Just sort of an expensive option, but worth considering for your management goals. Uh, I think that was the main stuff I wanted to say about Doug fir beetle, and I'm sure we got some questions. I want to just mention some other notable pathogens, which we could talk about in the questions, uh, or now we probably have plenty of time already. But dwarf mistletoe, I did want to talk about this, but kind of don't have time. It's a it's a notable concern for hemlock, a little bit for Doug fir. Um, Swiss needlecast is a disease of Douglas fir in the coastal fog belt, um, and has been pretty detrimental to plantations planted there over the last 40 years, but is really sort of a mismatch of planting Douglas fir plantations where there shouldn't really have been Douglas fir. So we don't really see needlecast that frequently in kind of drier sites or away from the coast where that fog belt causes issues. Flathead fir borer is a lot like the Douglas fir beetle, just not as prevalent, but not worth getting into too much more. White pine blister rust is, of course, like a historical disease that wiped out all the white pine in the region, and is worth considering if you're interested in planting white pine. Getting white pine that are resistant to the blister rust is really critical. And then drought-related decline is, of course, frequently in the news. Red cedar and hemlock, and maybe further south in Oregon and California, even Douglas fir is showing some drought-related decline. So it's just a big list of some of the pathogens and diseases that we've been working with here and that I see frequently with our clients. But I know I sort of blitzed through this, so I'd be happy to answer some questions. I forgot I've got some additional resources here. There's some great leaflets from the U.S. Forest Service I highly recommend, as well as the Washington, Oregon forestry websites. Um, Local foresters from the DNR, Washington State University, or the NRCS have a ton of expertise in this topic as well and can help you. And then, of course, your own foresters here at NNRG, we're happy to help. Shoot us an email, join our membership program, and we can give you some advice on working with or managing the pathogens that might be impacting your forest. So yeah, just wanted to open it up to any questions and review any topics or look at any of the photos that I might have blitzed through while I was presenting.
It's great. Thank you, Matthew. I definitely learned a few new things myself. We are happy to open it up for questions. You're welcome to either put questions in the chat, or if you're comfortable coming off mute, you're welcome to do so. If there are a couple of people who are interested in talking, you can raise your hand either virtually or in the video. So if there are any questions, I know one question that I kind of cropped up for me. Matthew, you do a lot of management plans. When you're going out to people's properties, and if you're seeing something like laminated root rot in a property, what's the tipping point for you when you would recommend a smaller non-industrial forest? Like, hey, this is something you should be paying attention to, getting ahead of, versus this is something you don't necessarily need to worry about. What's that tipping point for you?
Um, yeah, I think prevalence, um, how many acres are infected, and I just almost always recommend for hands-on landowners, to monitor regeneration in the mortality pockets and probably plant resistant species like um, that's the gold standard. We don't all have time to do that. Um, but it's never a bad idea to plant some resistant pine or cedar into those root rot pockets. That's probably always going to be pretty successful. Um, yeah, I have never recommended an actual sanitation cut or a stump removal or anything really serious. Um, I haven't seen the need, given people's management objectives, to ever do something like that. Um, yeah, I think that's the most common answer. And frankly, a lot of people with young forests don't really we wouldn't even know. Like I can't even tell you how to rot until the trees start dying, right? I mean, short of destructively sampling your trees, which we wouldn't do, it can't be known until a few more symptoms exhibit. So we may not always know the extent of the infestation to begin with. But it looks like we have a question in the chat.
Yeah. And you might want, if you stop screen sharing, we might be able to see
Sure.
folks as they come off mute. But
Yeah.
yeah, Gabrielle had a question in the chat. You mentioned white pine blister rust can be managed with planting resistant tree varieties. I hadn't heard of that as an option. Can you explain a bit more about that?
Yeah. Ooh, I don't know if I will say most, but many nursery stock today that are white pine are going to be from trees, genetic lineages that have exhibited resistance to white pine blister rust. White, so it was almost 100 years ago, or maybe a little over, that white pine blister rust arrived in North America, maybe from Europe, I'm not quite sure, and then decimated our white pine forests, probably most notably in the pure kind of white pine stands that used to exist in Idaho and Montana. But white pine was much more prevalent even in the Cascades. Um, but some trees survived, and from those surviving trees, there was tolerance and new seeds were established from those trees. And so if you inquire, you can ensure that you're planting a, a white pine that is resistant to the blister rust, which is like probably the only pine you shouldn't otherwise plant white pine because the blister rust actually lives on was it gooseberry, ribes? So it's just everywhere.
Hmm.
Uh, and so if you don't plant a resistant variety, you will just probably lose that tree shortly thereafter. Um, I don't know. Does that help you, Gabrielle? Yeah.
Yeah.
Yeah. So I occasionally see, 3 foot diameter white pine in the woods. It's very rare. There are a few survivors out there in the foothills. It's pretty cool to find them. That they survived for so long, but most of them did unfortunately succumb.
Kind of an amusing story. I bought a bunch of red flowering currant from a conservation district sale and planted it on my property, and then learned that the red flowering currant, a native plant, is a major host of the
Yeah,
blister rust. So
yeah,
um, hopefully that won't create some difficulty. But one question I had is, do you have any recommendations for those of us who want to take a stab at identifying our own tree pathogens, pests? Any uh, field guides or other resources on
Yeah.
with good photos, that sort of thing?
Well, so I mentioned leaflets and websites, but the best diagnostic key, there's gonna be two guides that I have on my phone. One is going to be U.S. Forest Service publication. Um, Here I have it right here. Uh,
Is that the USDA
um,
one?
does Field Guide to the Common. I don't know if we're gonna be able to get this. Maybe I'll put it in the chat. Yeah. It's Diseases and Insect Pests of Oregon and Washington conifers, and it's really well organized and extraordinary detail compared to what I've discussed tonight. And it has a decent diagnostic key, but I'm actually more of a fan of Field Guide to Forest Damage in British Columbia, which of course we're not in British Columbia, um, but there's a lot of species overlap, and I think it has the superior diagnostic key. It's just much easier to use to
Can
find
you
out.
can you restate the title of the BC one again?
Yeah, I'll put it in the chat. It's called Field Guide to Forest Damage in British Columbia.
The first one you mentioned, the USDA Field Guide to Common
Yep, I think
Diseases and
Rowan
Insect Pests.
Rowan just got it in the chat for
Yep,
me.
I just put the digital version in the chat, and here's the title for it.
Yeah, I think I downloaded the PDF of that elsewhere, and it is useful.
Yeah, it's a little overwhelming, right? And so it's hard to know what you have because there are just so many options. And which is why I tried to only mention like the ones that maybe matter or most likely to run into. I think sometimes some of these are more, academic. Uh, but yeah, the BC guide also includes, and why I like it a lot, includes abiotic damage, so non non-living damage from like frost or sun scorch or drought. So you can kind of get a more holistic view of what could be going on.
Mm. Thank you. This is very interesting.
Yeah. Oh, we have a local hero here, Joni Hendricks. Thanks to you, we have these white pine resistant varieties. That's wonderful to hear.
Under Boyd Wilson, great. We did have a earlier question from Bill in the chat. We are located in Eastern Washington. I received some white pine from our conservation district. Assuming they are rust resistant, what else should we be doing to help propagate white pine within our ponderosa pine stands?
Hmm. Yeah, let's assume they're resistant. And really in white pine, white pine is like the least shade tolerant and the least drought tolerant of the pines. So it's the pine closest to a fir, I like to say. And so you've got this ponderosa pine, right, that can just literally take it all. It's one of the most drought tolerant tree species. After ponderosa, he basically turns into shrub steppe or maybe a little bit of juniper. But it's got a high tolerance, right, for drought and needs a lot of light. And uh, white pine is one of the least drought tolerance. And I might have made a mistake. It's one of the most shade tolerant pines, so it's the closest to a fir. So you just need to manage for its innate silvicultural characteristics. So it can take a little shade, probably about as much shade as a Douglas fir, and so I could see it having some synergy in the Doug fir ponderosa pine region. But I'd be sort of worried about its drought tolerance. If you're in a stand that's growing ponderosa pine, I would be a little concerned how well the white pine will do. And I don't think so. I would really focus on micrositing, down in valley draws, areas that are going to have more water. Um, those would be the best sites to put your white pine, given its kind of relative lack of drought tolerance compared to ponderosa pine.
So we have a lot of wetlands that,
Yeah.
so we have aspen. So are we
Okay.
looking for some area between the ponderosa pines and the aspen?
Yeah. Is it wet all year or is it seasonally wet?
seasonally wet.
Yeah. Yeah, the white pine is interesting. I don't know its kind of waterlogging tolerance,
Mm,
but I would also really consider lo varieties of lodgepole are really effective in this kind of bimodal. They can sit in a bog and then they can dry out and stand tall through a drought. Um, Especially in like like in BC, kind of as you move north, a lot of the lodgepole exists in these kind of wet areas. Not so much like in Oregon where you'll see lodgepole kind of in high elevation stands, but
right.
lodgepole might be interesting, especially if you get the right seed zone. So much of sighting trees, trees have such amazing genetic diversity, one valley to the next, because they haven't really been able to move and mix as much as, animals can. So it
Mhm.
is really, critical to get the right seed stock, seed zone. I know NNRG has a lot of information on that topic. Um, but you might consider that. Um,
We're trying to think of anything
yeah,
to
yeah,
diversify the ponderosa.
yeah. No, it's a very interesting problem. Um,
Thanks.
yeah. Do we have any other questions?
Well, if not, I know we're getting close to the end of our hour together. Um,
I thought for sure someone was going to bring a picture of one of their trees and try to get me to diagnose it over the internet.
can definitely be kind of hard to see the details on that. Like, oh, is there lamination in that tiny little pixelation?
Uh-huh. That's what I would have done.
But yeah, VR forestry, we have a way to go on that.
Oh, that's right. We were talking about that the other day. VR, virtual
NNRG
reality.
always on the innovative cutting edge, but also a little bit of realism on what we can actually do without poking our fingers into a downed log.
Yeah.
Great.
Um, yeah, I was curious if I mean, does anyone here have kind of experienced any red cedar or hemlock decline on their properties that they're noticing? That's something I'd like to ask people to get a sense for where that's occurring.
I just went on a forest walk that was organized by the Clallam County Conservation District and DNR. And we visited a site that had a lot of really stream bed type wet sites where red cedars were growing. And oddly, some of the cedars that were in the wettest areas had the most flagging or tip dieback.
Hmm.
So it seemed like the decline of the red cedars um, wasn't really connected to droughty conditions. So
Yeah.
it's suggested that it's another or a real combination of factors that's causing the decline that we're all seeing.
Yeah, this has been studied for a long time. Yeah, I would have some like questions like, do you think it was water year round or was it like a site that goes dry at some point?
Yeah, year round.
Year round standing water?
Yep.
Yeah. Yeah. I mean, assuming they weren't like inundated and they had sufficient, uh, aerobic instead of anaerobic soil conditions, then yeah, that doesn't quite make as much sense because that's a lot of moisture. There's some really great work coming out of Oregon on this topic, but it's still no one has found like a pest or a disease. I think most things fit sort of neatly into the abiotic category, like drought, except for this example, so it requires more insight. But that's sort of been their conclusion, is they haven't been able to diagnose like a pathogen uh, yet. Uh, Diane has a nut cedar, winter wet, dry summer. Yeah. One of the things I remember from this paper about cedar was they also mentioned they were losing cedar in unexpected areas they thought they would do well But one of the major determinants was that there was no protective shade overstory. And so, we have to think about two things. It's moisture availability, but it's also moisture requirement. And so if you grow underneath a shaded overstory, the demands on your foliage to the amount of sun and air that's causing you to dry out is reduced. And it seems like cedar often thrives in this kind of mid-story position where it doesn't have to get its canopy up into the really kind of blasted sun and wind. Um, and that was sort of a finding from a paper a few years ago, that it was hard to sustain cedar on dry sites or even winter wet sites once they kind of got out there and got blasted by the winds. And there's a lot of different theories. Some people wonder if cedar would have ever been growing in that exact spot. And we have a whole, we're rarely talking about old growth cedar, right? We're talking about like second growth cedar or third growth cedar, young cedars. So there's theories about kind of species, site suitability, and a lot of species can propagate early in their lives across a wide range of conditions, but are really only suitable for a small, spectrum of those sites for the long term. So what would be really damning to me would be find an old growth cedar stump and then dying young cedar, right? To know that this site was sufficiently moisture and suitable to grow a big old 1,000-year tree, but then today it's not, right? That would be sort of really powerful evidence that something has changed. Otherwise, sometimes you see cedar growing on like a sandy bank, and you think that cedar just probably isn't well suited to that site. Once the first drought comes, this could reduce that cedar's survivability. But during the wet years, it does okay. But anyway, a lot of debate on that topic for sure. There's a great ODF has a great story map. I'll actually just Slack this over or put this in the chat. But then I bet we got to get going. Let me see if I can give you guys this before I go. Here we go. This is a really great. This link is a public called a story map about Western red cedar dieback and various research being led by the Oregon Department of Forestry. And they've got a lot of info on that. I would start with this, if you're interested.
Yeah, it's a great place to start. And WSU also has a forest health monitoring that has been tracking red cedar dieback as well.
Yeah, this is the WSU paper. Or one of the important WSU papers. Anyway, yeah.
Lots of reading material.
For the so inclined,
Well,
or just come out.
yeah, and I mean there are so many ways that you can go with the forest pathogens. It's there's kind of an endless set of resources to consult. I
Yeah.
know that we are at the hour, so unless there are any burning questions that folks want to pose to Matthew, I will thank you all for joining us this evening. Wish you a wonderful, cozy night in the stormy weather that we're having, and hope to see you all next month at our next fireside chat.